Okay then, let's take a look at what we're going to do here is we're going to do some more solving of right triangles. And the big question here is like, okay, so you gave me an angle on a side, and I can get the other side. But what if you gave me two sides of a right triangle, right? What if you gave me two sides? And could you give me the acute angle? And that's what we're going to do here. So in order to do this, I have to introduce what are called inverse functions. We're going to call them inverse trig functions. Okay, so the way an inverse function works is that if I have like the tangent of x is equal to some value y, see tangent is a function here, it's a function that returns a ratio, eats an angle, returns a ratio of two sides, then what I can do is I can rewrite this statement and say the inverse tangent of y is equal to x, so that tangent little -1 sign means inverse, so we just switch the x and the y. The same works for the sine and the cosine. So if the sine of x is equal to y or the cosine of x is equal to y, then the inverse sine of y is equal to x, and the inverse sine, or the inverse cosine, right, the inverse cosine of y is also equal to x. So if you think about this here, these functions are eating angle measures and returning side ratios, right? Here, these functions are eating side ratios, and these are returning angle measures. So if the problem is asking for an angle measure, you are using the inverse function. If the problem is asking for a side length, you're just using the standard functions themselves. So let's look at some examples of these. All right, so let's get a tangent example. So if I am playing with the tangent function, right, I have to have the opposite value and I have to have the adjacent value. And let's say I want the measure of angle A. Well, then I know that the tangent of angle A is the opposite over the adjacent, which means that, according to what we said earlier, the measure of angle A has to be the inverse tangent of that same reality. Now, this is simple because the calculator will do the work for me. Okay, so always remember that here in geometry class, when we're doing right triangle trigonometry, hit the mode. Make sure the calculator is in the degree mode. Its default is radian, so you got to make sure of that. And then let's see how we're going to take an inverse tangent. If you look at the tangent button, the little blue print above that says tangent inverse. So I say there's the tangent inverse of 3/6, and it tells me that I'm approximately 26.6 degrees. Okay, so there's the solution to my problem. Put the tangent inverse in using the second key, and it comes back with 26.6 degrees, give or take a little bit. So coming back to my problem, that means the measure of angle A is approximately 26.6 degrees. So there you have it. Okay, so if this is 3 and that's 6, this has got to be a 26.6 degree angle. So let's do a sine example. Right, so if I have a sine problem, a little bit different, but pretty much the same idea. In a sine problem, I have to have the opposite and the hypotenuse. So let's draw a triangle. Right, there's my right triangle. My opposite is 2. My hypotenuse is 6. So the sine of angle A has to be 2/6. I mean, you could reduce that to 1/3, but you don't even have to, because we just take the inverse, right? The measure of angle A should be the inverse sine of 2/6, which if you go and you throw that into the calculator, and I advise that you do that, this is going to be approximately 19.5 degrees. All right, so given these two values, I can find the measure of the angle. Now let's work a cosine example. Okay, so for the cosine, right, remember here's my triangle. And which two sides do I need for the cosine? Oh yeah, I need the adjacent and the hypotenuse. So let's make the adjacent 6, the hypotenuse 11. We'll call that angle A. right? So we know that the cosine of A is the adjacent 6 over the hypotenuse 11. So that means the measure of angle A has to be the inverse cosine of 6 over 11. And when I put that in the calculator, it works out to be roughly 56.9 degrees. So this is definitely not drawn to scale, because that's going to be more than 45. This is actually going to be the bigger of the two angles. But even with the lack of scale, I can come up with the correct answer. All right, so if you are given two sides of a right triangle, you can find the measures of the acute angles using the inverse trig functions, inverse tangent, inverse sine, inverse cosine, depending on which pair of sides that you have. All right, so there you go. Thank you.